Assalamualaikum and a very good day to all. Welcome to the second lecture of Managerial Economics. So last week we have already looked at the definition of Managerial Economics, where it is actually the branch of economics that tries to incorporate economic theories and tools of analysis of decision sciences to help managers solve problems in an organization. So the solution that we are looking for would be the best possible solution or the optimal solution. We have also learned that in this course, our main focus is the firm. So last week, we have already identified some of the objectives of the firms. And the main objective of the firm is actually to maximize profits. Okay. Apart from the economic goals, there are also non-economic goals that firms tries to achieve. So in this course, what we are trying to do is to help the managers to achieve all these objectives. In order to be able to find all this solution, there are several basic concepts that you have to learn. Last week we have already started with looking at the rules of differentiation, even though there are 6 rules of differentiation, but for this course you only need to know 4. So let us run through again some of these rules, okay, just to make sure that you still remember all 4 of them. Okay, so as I mentioned to you just now, there are 4 rules of differentiation that are very much important for this course. So the first one that you need to know is how to differentiate a power function. Okay, so remember, a power function is a function with an exponent. So when you want to differentiate, okay, this particular function, so all you need to do is you need to go through 3 steps. Okay, so if let's say you are given y equals to ax to the power of n, so to find dy dx, the first step requires you to bring down the exponent. The second step involve writing down the original equation, and the final step you need to reduce the exponent by 1 unit. So let's try one example just to make sure that you are fluent with this rule. Okay, so you are given y equals to 10x to the power of 3. Remember, if you want to find dy dx, there are 3 steps involved. So first you need to bring down the exponent. The second step, you need to write down the original function, which is 10x to the power of 3, and the final step involves reducing the exponent by 1 unit. Okay, so what you need to do next is you need to simplify this equation, and you're going to end up getting 30x to the power of 2. So if you manage to get this answer, so meaning that you already understand the first rule of differentiation. Okay, now let's move on to the second rule, which is the constant function rule. Now a constant function is a function with only a number. So if let's say you have y equals to a and you want to differentiate it, you will get 0. So it doesn't matter whether the equation equals to any number, but as long as it is a constant function and you differentiate it, you will get 0. So let's assume that you have y equals to 6.14. So if let's say you want to differentiate it, so can you guess what will be the answer? So the answer must be 0, okay, as 6.14 is actually a number. Okay, now the third rule is a line function. So a line function is in the form of y equals to ax. Okay, as you can see here, x has an exponent equals to 1. So if you want to find dy dx, you are going to get the number, okay, in this case a. So if you have y equals to 25x, okay, so remember your independent variable here is x and the number is 25. So if you want to find dy dx, so what should be the answer? So the answer should be 25, which is the coefficient, okay? And the last important rule that you need to know is a sum or difference function. Okay, so a sum or difference function is a function that involves subfunctions. So if you want to differentiate, okay, this particular function, what you need to do is you need to differentiate each of the component, okay, of the function using the three rules that we have covered just now. Okay, so if let's say you have y equals to x to the power of 3 minus 8x squared plus 57x plus 2. So if you want to differentiate it, okay, you can see that you need to differentiate the subfunction here. Okay, so there are different rules that you need to apply here. So for example, for the first subfunction, you need to use the power function rule. The same goes with the second subfunction. As for the third subfunction, you need to use the line function rule. And the last component requires you to use the constant function rule. Okay, so if you apply all these rules, so you're going to end up getting 3x to the power of 2 minus 16x plus 57 plus 0. Okay, or if you simplify this equation, so you're going to end up getting 3x squared, okay, minus 16x plus 57. So if you manage to get this answer, this means that, okay, you are already now very well versed with the rule of differentiation. Okay, now notice that, okay, all the example that we have looked at all involve a univariate function. Okay, so can you still recall what is a univariate function? Well, a univariate function is a function with one dependent and one independent variable. Okay, but what if you are given a multivariate function? Okay, so now what we're going to look at is how, okay, to differentiate a multivariate function. Okay, so a multivariate function is a function where you have one dependent and more than one independent variable. So here, okay, I have few examples of a multivariate function. So if you look at the first example, you have y equals to 3x squared plus 10z minus 3xz. Okay, so as you can see, your dependent variable is y, okay, which is the variable on the left hand side, and your independent variable comprised of x and z. So because you have more than one independent variable, so this function is what we call as multivariate function. Now, given a multivariate function, how are you going to differentiate this function? So to differentiate a multivariate function, you need to use a technique, we call it as partial differentiation. Okay, so partial differentiation requires you to differentiate the function with respect to each of the independent variable that you have. Okay, so again, if you look at the first example, since we have two independent variables, x and z, so if you want to differentiate it, you need to differentiate with respect to each of the independent variable. So what you need to do is, let's say you want to differentiate with respect to independent variable x, okay, or in other words, you want to find dy dx. So when you want to find dy dx, you have to assume the other variable, in this case z, as a constant or a number. Okay, now once you are done with that, next you proceed with differentiating the same function, but this time around with respect to z. Okay, when you differentiate the function with respect to z, you have to assume the other variable, in this case x, as a constant. So this process is what we call as partial differentiation. So what I'm going to do next is I'm going to show you in detail how I derive, okay, the answer for example 1. Okay, So let us look at the first example just now. So we have y equals to 3x squared plus 10z minus 3xz, and as I mentioned to you earlier, this is a multivariate function. So to differentiate this function, you need to use partial differentiation technique. Okay, so partial differentiation technique requires you to differentiate the function with respect to each of the independent variable. So what I'm going to do, first of all, I'm going to differentiate the function with respect to x. Okay, so when I do that, I have to assume the other variable, which is z, as a number. So if this is the original function, okay, so since I want to differentiate the function with respect to x, so the other variable, in this case z, okay, so we have 2z here, so you have to assume it as a constant. Okay, now another thing is that if you look at this function, it involves sum and difference, okay, and you still going to use, okay, the rules of differentiation that we have already looked at just now. All right, okay, so let's start with the first subfunction. Okay, you have 3x squared, and remember you want to differentiate this with respect to x. Now because this is a power function, definitely you need to use a power function rule. Okay, so how are we going to differentiate, okay, this power function? Now remember, because you want to differentiate with respect to x, what you need to do is you need to bring down the exponent for x. So in this case, 2. Okay, the second step, you need to write down the original function, which is 3x to the power of 2, and the third step requires you to reduce the exponent by 1 unit. So as you can see, the steps are actually the same, okay, as you did just now. Okay, so this is a power function, and remember you want to differentiate with respect to x. Okay, and for that reason you need to bring down the exponent for x, write down the original function 3x squared, and reduce the exponent by 1. So you are done with differentiating the first function. Okay, now let's moving on to the second one. The second subfunction is 10z. Now remember, you are differentiating with respect to x, meaning that z is a number. So 10 is already a number. So now you are assuming z is also a number. So meaning that the second subfunction is a constant. So if you can recall, okay, our rules just now, okay, if you have a constant function and you differentiate it, you're gonna get 0. Okay, so that's the product of differentiating the second subfunction. And the third subfunction is 3xz. Now this is a bit tricky, okay, because now you have both x and z. Now, but remember, you are assuming that z is a number, okay, z is a constant, and you want to differentiate with respect to x. Okay, now so the easiest way, okay, to solve, okay, or to work with a multivariate function is to always check which independent variable are you differentiating. Okay, so remember that you are differentiating the function with respect to x. So if you are differentiating the function with respect to x, so you always need to use the power function rule, okay, which means you need to bring down the exponent for x, write down the original function, and reduce the exponent for x by 1 unit. Okay, now so looking at 3xz, okay, so remember 3 is a number, z is a number, and we want to differentiate this subfunction with respect to x. So the rule says bring down the exponent for x. So in this case, the exponent is equals to 1. Okay, the next step is you need to write down the original function. Remember, okay, the second step of differentiating a power function, and the last step requires you to reduce the exponent for x by 1 unit. Okay, so if you have 3x, okay, understandably, okay, there is already 1 as an exponent, okay, so you have 1 minus 1, so this should be a superscript. So what you have here is, okay, so again let us, okay, look again at how we differentiate the last component ni. So remember, you are required to use the power function rule, okay, which make it much easier. So bring down the exponent for x, which is 1, write down the original function 3xz, and reduce the exponent for x by 1 unit, okay. So now what we're going to do is we're going to simplify this. So 2 times 3 is 6, x to the power of 1, so which you don't need to write the exponent 1, okay, plus 0, so you can just decide not to write plus 0, and then minus 1 times 3, which is 3, x to the power of 0, which is actually 1, okay, and remember z is a number, so simply write z, okay. So you can further simplify this, and you're going to get 6x minus 3 times 1 times z. So the partial derivative, okay, for this function dy dx should be 6x minus 3z. Now once you are done with differentiating the function with respect to x, the next thing is you need to differentiate the function with respect to z. Now when you differentiate the function with respect to z, you need to assume x as a constant. So now they switch rule. So remember, the first thing that you did just now, you were differentiating the function with respect to x, and you are assuming that z is a constant. Now the second, okay, process requires you to differentiate the same function but with respect to z. So when you're doing this, you have to assume x as a constant, okay. Now, how are you going to differentiate this function? You still apply the same rules of differentiation, okay. So let us repeat the same process, but this time around you are differentiating with respect to z. Okay, so let's look at the first subfunction. You have 3x squared. Now remember, you want to differentiate with respect to z. And what are you going to do with x? You have to assume x as a constant. So 3 is already a number. Now x, you are assuming as a number. So all this sub-function is a number. And if you are differentiating a number or a constant, you're going to get 0. So the derivative of the first sub-function is equals to 0. Now let us move on to the second sub-function, which is tan z. Okay, so remember, you want to differentiate with respect to z. Okay, so what you need to do is you need to use the line function rule. So remember, if you have tan z and you want to differentiate with respect to z, you're going to end up getting tan. Okay, and differentiating the last subcomponent 3xz. So remember, okay, you are differentiating with respect to z, meaning that x is a number. Okay, so if you differentiate 3xz, so what are you going to do? So again, remember, you are differentiating this function with respect to z. And okay, if you have two independent variable at the same time, so I would suggest that you use the power function rule. So since you are differentiating with respect to z, so what you need to do is, first of all, bring down the exponent for z, in this case 1, and then write down the original function 3x times z, and the last step that you need to do is you need to reduce the exponent for z by 1 unit. So we already have 1 as the exponent for z, and you need to reduce it by 1 unit. Alright, so remember that now we are differentiating the y function with respect to z, and when we are doing that, we need to assume x as a constant. Okay, so we have already differentiate, okay, the y function with respect to z. And now if you simplify this, you're going to get 10 minus 1 times 3, which is 3x times z to the power of 0. Now remember that anything with 0 as an exponent is equals to 1. So you're going to end up getting 10 minus 3x. So if you compare with our slide just now, okay, so this is actually how we derive to the answer. Okay, so I know that this is a little bit difficult, okay, but just to make sure that you can get hold of this concept, let us try with another example. Okay, so I have another multivariate function y equals to 80x minus 2x squared minus x times v minus 3v squared plus 100v. Now again, this is a multivariate function. So if you want to differentiate it, you have to use the partial differentiation technique. Okay. Now, if you want to use partial differentiation, you have to differentiate with respect to each of the independent variable. So since we have x and v, so you are required to differentiate with respect to variable x first. So when you are doing that, you have to assume v as a constant. Next is to differentiate the y function with respect to v, and while you're doing that, you have to assume x as a constant. So let us differentiate this function together. Okay, so we're going to start off by differentiating the y function with respect to x. Okay, remember v is a constant. Okay, now let's start with the first subfunction. So you are differentiating the function with respect to x. Okay, so and you have 80x. Now this function is a line function. If you have a line function and you want to differentiate it, you're going to get simply the coefficient. Okay, in this case 80. Let's move on to the second subfunction, which is 2x squared. Now remember, you want to differentiate the function with respect to x. And this is a power function. So the power function rules requires you to bring down the exponent, which is 2, write down the original function, 2x squared, and you have to reduce the exponent for x by 1 unit. Okay, so that's how you differentiate the second subfunction. Now we move on to the third subfunction. Now this is a little bit tricky because we have both x and v. But remember, you have assumed that v is a number. Okay, so if you want to differentiate, okay, this particular subfunction, the trick is to see which independent variable are you differentiating with. So remember, you are differentiating with respect to independent variable x. So if that is the case, you need to bring down the exponent for x. And the exponent for x here is actually 1. Okay, because if there's no exponent being written there, so understandably that the exponent must be equals to 1. Okay, and then you need to write down the original function, which is x times v, and you have to reduce the exponent for x by 1 unit. So remember, even though there is no exponent being written for x, but you have to understand that there is always 1. Okay, and you have to reduce the exponent by 1 unit. Okay, so that's how you differentiate the third subfunction. Okay, the fourth subfunction is 3v squared. Okay, remember, you are differentiating this function with respect to x, and you are assuming v as a number. So 3 is already a number, v is also a number. That means this subfunction is a number, and if you are differentiating a number, you should get 0. So the same thing with the last subfunction, which is 100v, because you are differentiating it with respect to x. So 100 is a number, and so does v. And to differentiate a constant function, you're going to get 0. Okay, so once you are done with differentiating all the sub-function, all you need to do is to simplify this. So you should get 80 minus 2 times 2 is 4 times x to the power of 1, which you don't need to write it down, minus 1 times x to the power of 0. So remember, anything with 0 as an exponent should be equals to 1. And multiply by v, you should get v. And minus 0 plus 0, you don't need to write anything. So you're going to end up getting 80 minus 4x minus v. Okay, but you are not done yet. Okay, so you are only solving half of it. Now remember, this is a multivariate function, so you need to do another differentiation. This time around, differentiate the function with respect to v. So when you do that, you have to assume x as a number. So you need to switch role. Okay, so you need to repeat the same process all over again, but bear in mind x is a number. So let's start, okay, the process again. We start off with 80x. Now remember that 80 is a number, x is also a number because you are differentiating it with respect to v. So since all these are number, if you differentiate it, you're going to get 0. Okay, let's move on to the second subfunction, which is 2x squared. 2 is a number, x is a number, so this whole subfunction is a number, and if you differentiate it, again you're going to get 0. The third sum function, now this is a bit tricky because you have x and v. So when you have two independent variable here, so the easiest way is to use the power function rule. Okay, so what we need to do is remember that you are differentiating with respect to v, so meaning that you have to bring down the exponent for v. Now even though there is no exponent being written for v, but understandably the exponent is equals to 1. Okay, the second step, write down the original function, and the third step, you need to reduce the exponent for v by 1 unit. So already, okay, there is 1, okay, as the exponent for v, and you need to reduce it by 1. Okay, and you are done with differentiating the third subfunction. Okay, let's move on to the fourth subfunction. You have 3v squared and you want to differentiate with respect to v. So again, you need to use the power function rule. So what you need to do here, bring down the exponent, write down the original function 3v squared, and the last thing that you need to do is you need to reduce the exponent by 1 unit. So as simple as that. Okay, and the last thing that you need to do is to differentiate 100v with respect to v. Now, if you can see here, this is a line function, and differentiating a line function will give you the coefficient. So now you can further simplify this, and you're going to end up getting negative x, okay, because negative 1 times x is x. V to the power of 0 is simply 1, so you end up getting negative x. And then minus 2 times 3 is minus 6. V to the power of 1, which you don't need to write, and then plus 100. So that's the partial derivative of your equation, your y function. So this is how you differentiate a multivariate function. You need to use the partial differentiation technique. Okay, now let us look at the second example. Now if you look at the second example, we have y equals to 10x squared and z to the power of 3. Again, this is a multivariate function, okay, because we have more than one independent variable. And because you are dealing with multivariate function, and if you want to differentiate it, you need to use the partial differentiation technique. Okay, so the question is, how are you going to differentiate this function? So first of all, you need to differentiate the y function with respect to x. When you are doing that, you have to assume z as a constant. So you're going to end up getting 20x times z to the power of 3. And then the second process requires you to differentiate the function with respect to the other independent variable, in this case z. So when you differentiate the function with respect to z, you have to assume x as a constant. So when you do that, you're going to get 30x squared multiplied by z squared. So how did you end up getting these answers? So let me show you in detail. So you have y equals to 10x squared multiplied by z to the power of 3. And as I told you, this is a multivariate function. So you have to differentiate this function with respect to each of the independent variable. So you may start with differentiating the function with respect to x, meaning that you want to find dy dx. When you do that, you are assuming z as a number. Okay. Now, how are we going to differentiate this function? Now, because this function have both x and z, so the easiest way is to apply the power function rule. Okay. Now, you are differentiating with respect to x. This requires you to bring down the exponent for x, in this case 2. The second step requires you to write down the original function, 10x squared to the power of 10x squared multiplied by z to the power of 3. And the third step requires you to reduce the exponent by 1 unit. And you are done. But this equation can be further simplified. So you're going to get 20 x to the power of 2 z to the power of 2. So that's how you differentiate the y function with respect to x. Okay, so you are partially done. Okay, now the next thing is you need to differentiate the function with respect to z. When you are doing this, you have to assume x as a constant. Now again, because we have both x and z in the function, it is advisable for you to use the power function rule. Okay, so remember, you are differentiating the function with respect to z. This requires you to bring down the exponent for z, in this case 3. The next step requires you to write down the original function. Okay, I'm going to show you in detail, okay, how we derive the answer for example 1. Okay, so let me bring you to a different page. Okay, so this, we are working on the same example, y equals to 3x squared plus 10z minus 3xz. Okay, now this is a multivariate function, and if you want to differentiate it, you have to differentiate with respect to each of the independent variable. So what we're going to do, we're going to start off by differentiating the function with respect to x. When you are doing that, you have to assume the other variable, in this case z, as a number. Okay, so once you are done with differentiating the function with respect to x, next you need to proceed with differentiating the function with respect to z. Now when you are doing that, you have to assume x as a number. So let us go through, okay, the workings of how we end up getting these answers. Yeah, so we want to find dy dx, okay, and we are assuming z as a constant. So you have to work on each of these subfunctions. So let's start with 3x squared. Okay, remember, you are differentiating it with respect to x. So you need to use the power function rule. Okay, and the power function rule requires you to bring down the exponent, write down the original function 3x squared, and reduce the exponent for x by 1 unit. Okay, so that's how you differentiate the first subfunction. Plus, now we want to differentiate the second subfunction, which is 10z. Now remember, we are assuming that z is a number. So 10 is already a number, and z is also a number. So meaning that this whole subfunction is actually a number or a constant. And if you refer to the rules of differentiation, if you differentiate a constant function, you will get automatically 0. Okay, so that's how you get 0 here. Okay, now minus. Now we want to differentiate the third function, the third subfunction. Now this is a bit tricky because you have both x and z. Now the tip is that if you have two independent variables at the same time and you want to differentiate it with respect to x, so what you can do is to use the power function rule. So it's much easier. Okay, now again, remember you are differentiating the function with respect to x and you want to use the power function rule. So what do you need to do? The first rule is you need to bring down the exponent for x. Okay, so even though there's no exponent here, but you need to understand that there is 1. Okay, so the exponent is equals to 1, so you bring down the exponent for x here. The second step requires you to write down the original function, which is 3xz. Okay, and remember the exponent for x is already 1. Okay, and the third step, you need to reduce the exponent for x by 1 unit. Okay, so that's how you get -1 here, because originally it's like this. Okay, so you bring down the exponent for x, which is 1, you write down the original function 3xz, and the third step, you need to reduce the exponent for z by 1 unit. So if you simplify this, you're going to get 6x plus 0, you don't need to write it down, and then minus 1 times 3 is 3, x to the power of 0 is equals to 1, z is simply z. So you're going to end up getting 6x minus 3z, which is the same as the answer which I showed you on the slide just now. Okay, so you are partially done. So next thing is you need to differentiate the function with respect to z. So when you're doing this, you have to assume x as a constant. So you need to switch rule, okay, and repeat the same process. So again, start with 3x squared. Now remember, you are differentiating it with z, and x is a number. So 3 is already a number, x is a number, so the whole term here is a number. So differentiating a number will give you 0. Okay, moving on to the second subfunction, which is tan z, and you want to differentiate it with respect to z. So again, this is a line function, okay, and if you differentiate it, you're going to get the coefficient, in this case 10, okay, minus 3xz. Now we want to differentiate 3xz. Now as I said, when you have both independent variable at the same time, what you can do is to apply the power function rule. Okay, so how do we apply our power function rule here? Okay, so remember, we are differentiating with respect to z. This requires you to bring down the exponent for z, in this case 1. Okay, so even though there's no 1 being written here, but understandably the exponent for z is equals to 1. So that's how you end up getting 1 here. Okay, the second step requires you to write down the original function, which is 3xz. Okay, so I purposely put 1 as the exponent. Okay, and then you have to reduce the exponent for z by 1 unit. Okay, so if you simplify this equation, you're going to get 10 minus 1 times 3 is 3, x is x, now z to the power of 0. So anything with 0 as an exponent should be equals to 1. So you're going to end up getting 10 minus 3x. Okay, so that's how we differentiate the y function. Okay, now just to make sure that you understand the concept of partial differentiation, we're going to try another example. Okay, now this is a bit longer function. You have y equals to 80x minus 2x squared minus xv minus 3v squared plus 100v. Okay, now what we are going to do is we want to differentiate the function. Since we have two independent variables, you are required to use the partial differentiation technique. So first of all, you differentiate the function with respect to x. When you're doing that, you have to assume v as a constant. The next step requires you to differentiate the function with respect to v, and when you're doing that, you have to assume x as a constant. Alright? Okay, now let's start with differentiating the function with respect to x. Remember, v is a constant. Let's start with 80x. Okay, so this is a line function. Okay, you want to differentiate it with respect to x, so you're going to end up getting 80 minus, you write it down as minus. Now the second subfunction is a constant function, 2x squared. So you simply follow the power function rule. You have to bring down the exponent, which is 2, write down the original function, 2x to the power of 2, and the third step requires you to reduce the exponent for x by 1 unit. Okay, the third one is xv. Now this is a bit tricky, but as I mentioned to you previously, if you have both independent variable, so you better use the power function rule. Now you need to check again, which function are you differentiating with? So you are differentiating with respect with function x. So what you need to do is you need to bring down the exponent for x. In this case, it is 1. Okay, write down the original function. So the original function is xv. So I put 1 as the exponent, okay, because eventually the third step will require you to reduce the exponent by 1 unit. So you are done with differentiating the third subfunction. Moving on to the fourth subfunction, we have 3v squared. Remember, 3 is a number, but v is also a number because we are differentiating with respect to x. So if you differentiate a number, you're going to end up getting 0. The same goes with the last subfunction, which is 100v. They are both numbers. So if you differentiate this, you're going to get 0. So simplifying this term, you're going to end up getting 80 minus 4x minus v. Okay. Next, you're going to differentiate the function with respect to v. So when you're doing this, you have to assume x as a constant. So you repeat the same process. First of all, you differentiate 80x. But remember, x is a number. So this whole term is a number. To differentiate it, you're going to get 0 minus, write down minus sign here. So the second subfunction is 2x squared. But because you are assuming x as a number, so this whole term is a number. When you differentiate it, you're going to get 0. The third function, you have both x and v, so it would be better if you use the power function rule. Now remember, you are differentiating with respect to v, so meaning that you have to bring down the exponent for v. So the exponent for v here is 1. Okay. The second step, you need to write the original function, x times v. Okay. And then the third step requires you to reduce the exponent for v by 1 unit. Okay. The third subfunction is 3v squared. You want to differentiate with respect to v. So you're going to end up getting, okay, you need to bring down your exponent 2. Write down the original function, 3v squared. And the third step, you need to reduce the exponent by 1 unit. And the last function, 100v, this is a line function. So if you differentiate it, you're going to get 100. So if you simplify it, you're going to get negative x minus 6v plus 100. Okay? Alright, so that's how you differentiate a multivariate function. Now let us move on to the second example. Okay, so the second examples here, okay, we have y equals to 10x squared multiplied by z to the power of 3. Okay, so this time around you have a multiplicative function. It is still a multivariate function because you have more than one independent variable. So how do we differentiate this? So let me show you in detail. Okay, so we have here, okay, your example just now, y equals to 10x squared multiplied by z to the power of 3. Okay, so because this is a multivariate function, you have to perform partial differentiation. So you need to differentiate with respect to x. When you are doing that, you have to assume z as a constant. The next step requires you to differentiate the function with respect to z, and when you're doing that, you have to assume x as a constant. Now let us start, okay, with dy dx. Okay, now remember this is a multiplicative function, okay, because there's no negative sign, there's no positive sign. All you have here are power functions. Okay, so if you want to differentiate the function with respect to x, so what you need to do here is you need to bring down the exponent for x. So what's the exponent for x here? It's 2. So you have to bring down the exponent for x. That's the first step. The second step, you need to write down the original function. So these are the original function, 10x squared multiplied by z to the power of 3. And the third step is to reduce the exponent for x by 1 unit. Okay, because you are differentiating with respect to x. Yeah? So when you're doing that, you're going to end up getting 2 times 10 is 20. X to the power of 2 minus 1 is 1. And z to the power of 3. Okay, so that is the partial derivative, okay, the first partial derivative equation, which is dy dx. Next, let's differentiate the function with respect to z, right? So when you differentiate the function with respect to z, you have to assume x as a constant. So again, we want to use the power function rule. So because we are differentiating with respect to z here, so you have to bring down the exponent for z. Okay, so the exponent for z is 3. So bring down the exponent for z, which is 3. Write down the original function, 10x squared multiplied by z to the power of 3. And the third step is you need to reduce the exponent for z by 1 unit. So at the end of the day, you're going to get 3 times 10, which is 30, x to the power of 2, and z to the power of 2. So that's the partial derivative equation, okay, for your y function. So that's how you differentiate your y function. Okay, so would you like to try another example? Okay, so another example, okay, we have a similar example, but this time around your independent variable is k and l, and your independent variable is q. So if you want to differentiate the function, you need to use partial differentiation technique. So what you can do, you can start off by differentiating the function with respect to l, and when you're doing that, you have to assume k as a constant. The second process requires you to differentiate the function with respect to k, and when you're doing that, you have to assume l as a constant. So let's start. Okay, so we want to differentiate the function with respect to l. What you need to do is you need to bring down the exponent for l. In this case, it is 0.8. The second step requires you to write down the original function. So the whole thing here is your original function. Okay, and the third step, you have to reduce the exponent for l by 1 unit. Okay, so this function can be further simplified. Okay, so you're going to end up getting 0.8 times 100, that should be 80, k to the power of 0.5, and l to the power of 0.8 minus 1, that will give you negative 0.2. So your first partial derivative equation is 80k to the power of 0.5 L to the power of negative 0.2. Okay, so let's differentiate the function with respect to k. Remember, when you're doing that, L is a number. Okay, so when you differentiate the function with respect to k, you need to bring down the exponent for k. In this case, it is 0.5. Second step, write down the original function. Okay, and the third step, you have to reduce the exponent for k by 1 unit. Okay, because you are differentiating with respect to k, so you have to reduce the exponent for k. So if you simplify this, you're going to get 50 k to the power of negative 0.5 and L to the power of 0.8. So these are the partial derivative equation for your Q function. Okay, so I hope that when you go back, okay, so you can try and work on your partial differentiation technique. Okay, so you can work on the third example, which is y equals to 20t plus 5n plus 20tn minus t squared minus 10tx minus 5nx plus 100x. So this is a very long function. So why don't you try on your own and see whether or not you can find the partial differentiation. Okay, so far we have already looked at the partial differentiation technique. Okay, so we have learned how to differentiate a univariate function. So that's the first part of the differentiation technique which I have taught you. And then I have also shown you how to differentiate a function which have more than one independent variable. In this case, your multivariate function. Okay, so bear in mind that for multivariate function, you need to use partial differentiation. Okay, now apart from the rules of differentiation, okay, the second thing that you need to know, okay, for you to work on problems of managerial economics is how to solve simultaneous equation. Okay, now what happens is that if, let's say, you are given two equations, okay, in this case 6x minus 3z equals to 0, and another equation is 10 minus 3x equals to 0, okay, and you are asked to solve the equation simultaneously. So how are we going to do this? Okay, so again, let me show you in details. Okay, so how we solve simultaneous equation. Okay, so we're still using the same example here. 6x minus 3z equals to 0 and 10 minus 3x equals to 0. Okay, so you are asked to find the values of x and z. Now, because you have two equations, you cannot solve both at the same time. Okay, so what you need to do is you need to reduce the equation into one. Okay, but the problem is, how are you going to do that? Okay, so there are various ways in which you can solve equations simultaneously. You can use the substitution method, or you can add or subtract the two equations. Okay, but what I'm going to do here is I'm going to use the substitution method. Now, if you look at the second equation, okay, you can see that it can be further simplified, isn't it? So we have 10 minus 3x equals to 0. Okay, you can also write this as 3x equals to 10. It's the same thing, isn't it? So you are just bringing the numbers to the other side. Okay, now you can further simplify this into x. So to find x, okay, you need to bring 3 to the other side. So that will give you 10 over 3, and you're going to end up getting 3.33. Okay, so now because you are able to solve for one independent variable, so definitely you can solve for the other one, okay, the other independent variable, in this case z. So what you need to do is simply substitute, okay, your x 3.33 into your equation 1, okay, and you're going to end up getting 6x, okay, so 6x, x you have found it to be 3.33, okay, minus 3z equals to 0. So you're going to have 3z equals to 6 times 3.33, okay, so if you want to solve for z, okay, you're going to end up getting 6.67, okay. So that's how you solve equation simultaneously, okay. So that's another thing that you need to know. Now another calculus technique that you need to know is how to solve a quadratic function, okay. Now a quadratic function is a function where the highest exponent is equals to 2, okay. So an example would be x squared minus 3x plus 2 equals to 0. So if you are asked to find the value for x, there are 3 ways in which you can solve it, okay. So method 1, you can use factorization, okay. So factorization requires you to find the factors for x squared and 2, okay, and you need to do it in such a way that when you cross multiply, you're gonna end up getting to the original function of x squared minus 3x plus 2, okay. So once you are able to factorize it, so you can solve your equation. So you can see that the values for x is going to be 1 or 2. Another method is for you to use a formula, okay. So the formula says that if you want to solve for x, okay, you need to use this formula. It's negative b plus minus, and you need to find the square root of b squared minus 4ac, and you have to divide everything by 2a, okay. So if, for example, okay, you have x squared minus 3x plus 2 equals to 0, the value of a is equals to 1, the value of b is actually negative 3, and c is your constant, in this case 2. So what you need to do is you need to substitute all these values into this formula, and you're going to end up getting the same answer, which is 2 and 1. Okay. Now the easiest method, and the method which I recommend you to use, would be by using calculator. Okay, so all you need to do is you need to have a scientific calculator, okay, and all you need to do is you just follow these steps. Okay, so if you have the calculator with you, what you need to do is you need to press the mode button 3 times, okay, and then you press 1, okay, for calculation, and then you press the right arrow button once, okay, and then choose 2 for degree, and you'll be asked the value of a, question mark. So this is where you're going to enter the value of a, b and c, which you have identified just now. Okay, so when the calculator requested the value of a, you simply type in 1, and then you press the equal sign, and then you're gonna ask to enter the value for b. In this case, your b value is negative 3. Again, press equal sign, and finally you are required to enter the value of c, in this case 1, and then press equal sign, and you'll be given the same value for x, okay, which is 1 and 2. Okay, so if you want to solve a quadratic function, so there are 3 ways of doing it. Alright, so far, okay, I have already highlighted to you all the calculus technique that you need to know for this course. Okay, remember, you need to know the rules of differentiation. The second thing, you need to know how to conduct partial differentiation. The third thing is how to solve equations simultaneously. And the last one is how you solve a quadratic function. Okay, so if you are able, okay, to understand all these 4 calculus technique, then you shouldn't be having any problems. Okay. The next technique that we're gonna look at today would be optimization technique. Now remember, in managerial economics, our main aim is to find the best possible solution. Okay, and this coincide with the calculus technique, which is optimization. Okay, so what is actually optimization? Now, optimization is the process of determining the best possible solution to a given problem. Okay, so as you can see here, the definition of optimization actually matches, okay, the main focus of managerial economics, which is to find the best possible solution. So in calculus, to find the optimal values, okay, you are required to find the maximum or a minimum value of a function. Okay, so how do you find a maximum or a minimum value? Okay, so there are 2 steps actually. So the first step, you need to find the first derivative function. Okay, so once you are able to find the first derivative function, you need to set the function equals to 0. Okay, so that will give you the optimal value. Okay, so remember, if you want to find the optimal value, what you need to do is to first of all differentiate the function once. The next thing is you have to set it equals to 0 and solve it. Okay, but if you want to determine whether or not the optimal value is a minimum or a maximum, this requires you to proceed to the second derivative. Okay, the second derivative requires you to differentiate the original function once, or you simply differentiate the first derivative function. Okay, so the rule here is that if the second derivative function is a positive value, then your optimal value is a minimum. But if your second derivative function has a negative value, then the optimal value that you found is a maximum. Now let us try and see some of the managerial problems which require managers to find the optimal solution. Okay, now you are given a demand function. Okay, and this demand function is represented by P equals to 30 minus 2Q. Okay, where P is price and Q is the number of output available. Okay, now you as a manager are required to find the amount of output that will maximize total revenue. Now this is a managerial problem, okay, because your main objective here is to maximize total revenue, and you want to identify how many outputs to produce. Okay, so whenever, okay, you want to maximize or minimize certain function, this is optimization. Okay, and if you refer back to the optimization definition, it says that this is a process of finding the best possible solution. Okay, and you are required to differentiate the function once and set equals to 0. So because your main aim is to maximize total revenue, so this is optimization, right? So you have to differentiate the total revenue function and set it equals to 0. Okay, so now you are given P equals to 30 minus 2Q. Okay, but remember, your main aim is to maximize total revenue here. Okay, so what do you need to do? Okay, so as I said just now, whenever you want to maximize or minimize a function, that is optimization problems, and you are required to differentiate the function and set equals to 0. So because you want to maximize total revenue, so you have to differentiate total revenue function and then set it equals to 0. Okay, but the question is, what is your total revenue function? Because there's no total revenue function given. Okay, now total revenue is simply P times Q. Okay, price multiplied by quantity will give you total revenue, which is your sales value. Okay, but if you want to find total revenue function, you need to have a P function. Okay, so what you need to do here is you need to take this P function and then plug it into your total revenue function here. Okay, so that's why we have 30 minus 2Q, that's your P function, and then multiply it by Q. So what you need to do is simply cross multiply. So 30 times Q will give you 30Q minus 2Q times Q will give you 2Q squared. So now you have your total revenue function. So let's go back to the problem. You want to maximize total revenue. So what do you need to do? You need to differentiate the function and then set it equals to 0. Okay, so this is your total revenue function. How are you going to differentiate the function? Now, first you need to differentiate the first subfunction, which is 30Q. This is a line function. If you differentiate it, you're going to get 30. Okay, minus, write it as minus. The next subfunction is 2Q squared. Now, this is a power function, so you are required to differentiate it using the power function rule. So you're going to end up getting 4Q. So if you differentiate your total revenue function, you're going to get 30 minus 4Q, and remember you have to set it equals to 0. So solving this equation, you're going to get Q equals to 7.5. So this is what we call as the optimal value. Okay, so to maximize total revenue, the manager needs to ensure that they produce 7.5. Okay, so we have already found our optimal value, but if you want to confirm that this Q value is able to maximize total revenue, or in other words, it is a maximum value, what you need to do is you can conduct what we call as the second derivative test. So the second derivative test requires you to differentiate the original function twice, or in other words, you can differentiate the first derivative function. Now your original function is TR. Okay, 30Q minus 2Q squared. This is the original function. When you differentiate the first derivative, when you differentiate the total revenue function once, you're going to get 30 minus Q. So this is what we call as the first derivative function. Okay, now if you differentiate the first derivative function, okay, you're going to end up getting minus 4, isn't it? Because differentiating 30 will give you 0. Differentiating minus 4Q will give you minus 4. So if you find the second derivative function for total revenue, you're going to end up getting negative 4. Now, negative 4 is a negative value. So if you refer to the guidelines which I gave you just now, so if your second derivative has a negative sign, then the optimal value that you have calculated is a maximum. So in this case, your Q equals to 7.5 is actually a maximum because you have proven that through the second derivative test, the value is a negative. Okay? Now, let us try another example. Okay, now let's say that a company is facing a total cost function q to the power of 3 minus 12q squared plus 60q. Okay, now you would like to know at what output level is average cost minimized. And the second part of the question, you are required to find the value of the minimum average cost. Now this question, okay, you need to divide it into two parts. Okay, so let's answer the question part by part, right? Okay, if you look at the main objective, it is for you to find Q. Okay, you want to find Q. Okay, what's Q? Okay, you want to know what's Q. Okay, which Q? The one that minimize average cost. Okay, so you want to find Q that minimize your average cost. So remember, whenever you want to minimize or maximize something, this is an optimization problem. And to optimize, okay, a function, you are required to differentiate the function once and set equals to 0. So because you want to minimize average cost, what you need to do is you need to differentiate average cost function and set equals to 0. That's what you are required to do. Okay, so you need to differentiate, okay, your average cost function with respect to Q, and then you need to set it equals to 0. So that's how you optimize a function. Okay, but the problem is there is no average cost function given. You are only given total cost. But this is not a problem, because as long as you are given total cost function, we can find average cost. Okay, now average cost is total cost divided by Q. So if you want to find average cost function, you have to divide the total cost function by Q. So this is your total cost function. You have to divide each one of the sub-function by Q. So Q to the power of 3, you divide it by Q, will give you Q squared, minus 12Q squared divided by Q will give you 12Q, plus 60Q, you divided it by Q, will give you 60. So this is your average cost function. So going back to the main objective of this particular firm, where they are interested to find the value of output that can minimize average cost. And you are told that you are required to differentiate average cost and set equals to 0. So because you have your average cost, what you need to do is you need to differentiate the function. So let's differentiate it. So Q squared, this is a power function. If you differentiate it, you're going to get 2Q minus, if you differentiate 12Q, so this requires you to use the line function, you're going to get 12. But if you differentiate 60, which is simply a number, you're going to end up getting 0. So what you're going to have is 2Q minus 12. And remember, you have to differentiate it equals to 0, isn't it? So 2Q minus 12 equals to 0. So you can solve for Q. You're going to end up Q equals to 6. So to minimize average cost, you have to make sure that the value of output is equals to 6. But you are not done yet, because the second half of the question wants you to find the minimum value of average cost. So what's the minimum value of average cost? To find the minimum value of average cost, what you need to do is to simply substitute Q equals to 6 into your average cost function. Okay, so when you do that, you're going to get the average cost value to be equals to 24. Alright, let us move on to the next example. Okay, so this is where you are required, okay, to determine the level of output that maximize profit. Okay, yet again, this is an optimization problem because you want to maximize profit. Okay, so the question is, to maximize profit, what is the output level? Okay, so remember, your main aim is to maximize profit. Okay, but to maximize profit requires you to differentiate, okay, your profit function, and then you have to set it equals to 0. So this is the thing that you need to do. Okay, but the question is, what is your profit function? Okay, so the first thing that you need to do is you need to come up with the profit function. Okay, so profit is actually the difference between total revenue and total cost. Okay, so you are given your total cost function. Okay, you are also given your Q function. Okay, so bear in mind that based on this Q function, the P function is going to be 110 minus 2Q. Okay, and your total revenue function is therefore P times Q, so you're going to end up getting 110Q. Okay, 110Q minus 2Q to the power of 2. Okay, so that's your total revenue function. So once you have your total revenue function and total cost function, you can come out with your profit function. Okay, so this is how you derive your profit function. Okay, so once you have your profit function, what you need to do is you want to maximize it. Okay, and remember, to maximize the profit function, you have to differentiate the profit function and set it equals to 0. So why don't you try and derive the profit function and see if you are able to get the optimal value to be equals to 22.71. Okay, now you can also solve this problem using another approach. We call it as marginal approach. Now if you want to maximize profit, another way of doing it is to set MR equals to MC. So apart from differentiating profit and set equals to 0, you can also equate MR function equals to MC function to get to the maximum profit objective. Okay, so you're going to end up getting to the same value. Okay, so I will leave it to you to try this example and see whether or not, okay, you will derive to the answers as I've shown you here. Okay, right. So all the three examples, okay, requires you to optimize a function, and these functions are all univariate function. Okay, but what if you are dealing with a multivariate function? Okay, so this brings us to the next, okay, section. We want to find out how to optimize a multivariate function. Okay, now we have here a function, okay, where y equals to 50 plus 18x plus 10z minus 5xz minus 2x squared. So you can assume that this is a profit function, okay, for a company, and this company is producing two products, product X and product Z. Okay, so the question is, if the firm wants to maximize Y, in this case profit, how many X and how many Z should it produce? Okay, now remember, our main aim is to maximize profit. In this case, it is Y. Okay, Whenever we want to maximize a function, we have to differentiate the function and set equals to 0. But the thing is, we are dealing with a multivariate function. So how are we going to differentiate it? So you need to use the partial differentiation technique. Okay, so first of all, you need to take all the partial derivative and then you set equals to 0. But because you have more than one equations, you have to solve it simultaneously. So this is where, okay, you apply, okay, the technique for solving equations simultaneously, which I have shown you previously. Okay, so given the profit function, okay, how do we differentiate it? Okay, let's say that we want to differentiate the function with respect to x. Okay, so when you're doing that, remember you have to assume z as a constant. Okay, so let's differentiate this. So you have 50, which is a number. If you differentiate it with respect to x, you're going to get 0. The next component is 18x. Okay, you differentiate it, you're going to get 18. Okay, plus 10z. Now remember, we are differentiating with respect to x, meaning that z is a number. So 10 is a number, z is a number. So if you differentiate it, you're going to get 0. The next one, you have 5xz. Okay, remember, you have to use the power function rule. So you should end up getting 5z. And the last component, if you differentiate it, you're going to get 4x. Okay, so this is the product of differentiating the y function with respect to x. Now you need to differentiate the function with respect to z. Okay, so first of all, okay, you differentiate the first subfunction, you're going to get 0 because it is simply a constant. The second subfunction is 18x, but remember, you are differentiating the function with respect to z. Okay, so meaning that x is a number. So 18 is a number, x is a number. So if you differentiate it, you're going to get 0. Next, you have 10z. You want to differentiate it with respect to z, you're going to get 10. The next component, you have 5xz. Okay, you differentiate it, you're going to get 5x. And the last subfunction, 2x squared, because you want to differentiate it with respect to z, so these are all constant, and you're going to get 0. So when you differentiate your y function with respect to z, you're going to end up getting 10 minus 5x. Okay, so what you need to do next is you need to set each of the partial derivative equation equals to 0. Okay, so dy dx, 18 minus 5z minus 4x, you set it equals to 0. And then the other function, dy dx, equals to 10 minus 5x equals to 0. Okay, so you have two equations with two unknown variables. So how are you going to solve it? So this is where you're going to use simultaneous equations method. Yeah, so simultaneous equation method requires you to either use substitution, or you can subtract or add the two equations. But what I'm going to do is I'm going to simplify the second equation and then substitute into the first equation. Okay, so from the second equation, we have 10 minus 5x equals to 0. Now, you can see that you can simplify it further, okay, into 5x equals to 10, isn't it? So 10 minus 5x, this is the same thing as writing it as 5x equals to 10. Okay, so when you solve this equation, you're going to end up getting x equals to 2. So once you found the value of x, definitely you can find the value of z. And how are you going to do that? Simply by substituting this value into the first equation, and you're going to end up getting z equals to 2. Okay, so if you want to maximize your y function, in this case your profit function, you have to make sure that x equals to 2 and z equals to 2. If you are interested to know, to find out how much is the maximum value for y, all you need to do is to substitute the value of x and z into your y function. Okay, and you're going to get your y value to be equals to 78. The next one, okay, is what if, okay, you want to achieve your objective, but this time around you are facing a constraint. Okay, so the previous examples that we are dealing with, it doesn't involve any constraint. Okay, you want to maximize your y function, okay, and you need to find out how many x, how many z to produce. Okay, there is no indication of a constraint. Okay, but what if you want to achieve your objective, but there is a limitation? Okay, so okay, let's look at this example. You have a firm which tries to minimize cost of production, okay, and the cost of production is given as 3x squared plus 6y squared minus xy, where x is the output produced by line 1 and y is the output produced by line 2. Okay, now that is a constraint faced by the firm in the sense that they can only produce a total of 20, okay, products. Okay, so the sum of product x and y that they can produce is equals to 20. Okay, so how are you going to minimize total cost function given the limitation in the form of your production capacity? Okay, so there are two ways of solving this. Okay, you can use the substitution method or the Lagrangian method, but for this course we are only concentrating on the substitution method. Okay, you don't need to worry about the Lagrangian method. So let us look at how, okay, we try to achieve minimum cost of production given the production constraint. Okay, okay, now when you use substitution method, what you need to do is you need to incorporate the constraint into the main objective. Okay, now remember that your main objective is to minimize total cost. So in this sense, your objective function is your total cost function. Okay, now you are also being faced with a constraint. The constraint is that the total number of product x and y that can be produced is equals to 20. Okay, so meaning that, okay, x plus y equals to 20 is what we call as the constraint function. So when you use substitution method, what you need to do is you need to find ways to incorporate, okay, your constraint into this objective function. Okay, so this is your objective function. So the easiest way, okay, to incorporate, okay, the constraint function into the objective function is for you to simplify the equation. Okay, so as you can see, okay, you can bring y to the other side of the equation, so that will leave you x on the left hand side of the equation, but on the right hand side of the equation you're going to have 20 minus y. Okay, so once you rewrite, okay, your constraint function, what you can do is you can substitute into the objective function. So whenever you have x, you have to substitute it with 20 minus y. Okay, so you have TC equals to 3x squared, but remember x is equals to 20 minus y, so you substitute that in, plus 6y squared, so that's okay, minus x. So every time we have x, you have to substitute it with 20 minus y, and then simply write y. Okay, so once you have this, So you cross multiply, you try to expand it, so you're going to end up getting TC equals to 1200 minus 140y plus 10y squared. So this is a new objective function after you have incorporated the constraint, okay, the production constraint. So when you are done with that, what you can do is you can try to find the solution for your problem. So remember, your main objective is to minimize total cost. Okay, so to minimize total cost, according to the optimization rules, you are required to differentiate the total cost function and then set it equals to 0. Okay, so if you differentiate the total cost function, you're going to get what? So differentiate 1200 will give you 0. Differentiating negative 140y will give you negative 140. Okay, plus, okay, if you differentiate, okay, 10y squared, you will get 20y, and this should be equals to 0. Okay, so that should be equals to 0. So if you solve this equation, you're going to get y equals to 7. Okay, so once you have solved the value for one variables, so definitely you can find the value for x. So because you know that x plus y is equals to 20, so if y is equals to 7, so definitely x must be equals to 13. So to minimize total cost given the constraint, you're going to see that the total amount of y to be produced must be 7 and the total amount of x must be equals to 13. And notice that when you sum up the two value, you still fulfill the requirement, the limitation, which is 20 units. Okay? Now, you can proceed by finding the minimum value of total cost if you are interested to do that. So what you need to do is simply substitute the value of y and x into your total cost function, and you're going to end up getting 710. So in this case, if you want to minimize total cost function given the production constraint, you're going to see that y should be equals to 7, x must be equals to 13, and the minimum total cost that you're going to achieve is actually 710. Okay, and that's how you solve or you optimize a multivariate function given a constraint. Okay, so what we have done today is to look at some of the important calculus technique, okay, for the cost, particularly partial differentiation, how to solve simultaneous equation, and how to solve a quadratic function. Okay, I have also introduced you to the concept of optimization, which is the most important concept in this course. Okay, always remember, whenever you want to optimize a function, in other words, if you want to maximize or minimize a function, you have to differentiate the function once and set equals to 0. So I have shown you several examples. Okay, so the first example is actually dealing with a univariate function. The second example, we are dealing with a multivariate function, but there is no constraint given. And in the third instances, we are dealing with a multivariate function, but given a constraint. Okay, but looking at, so even though we are dealing with three different types of function, but the general rule is that every time you want to minimize or maximize a function, you need to differentiate the function once and set equals to 0. So I really hope that you can try and do some exercises, okay, related to topic 2 to see that, to check whether or not you understand all the concepts that we have covered today. Okay, so thank you.